Hello everyone and welcome to this HyperSim tutorial. In this fourth session, we will be presenting the test automation tool that is called TestView. The core goal of this presentation is really to show how TestView and its key features are working. To do so, I would be presenting two examples. The first example will be built from scratch, and the intention is really to show how the mechanics, how the key features, and how the interaction between TestView and HyperSim is happening. The second example is really more industry representative to show how far we can bring and how far a project can go using a test automation tool such as TestView. Of course, before that, let's start by doing a quick recap of what is TestView and when it is useful or perhaps not useful too in certain situations. As mentioned earlier, TestView is intended for test automation. What do we mean by test automation? We're referring to the next step after modeling. Once a model is functional, then it can be submitted to repetitive testing. During those repetitive testing, the key elements are often to do the data recording, to do some post or during the test sequence analysis, to have some graph generation, and also to have some report generation. In a nutshell, asking someone to do the same task over and over again will always be inefficient. This is where TestView comes in. More practically is to insert the test automation that was described in the previous slide. As you could also see, it has a simple and user-friendly graphical interface that we will be showing into more details in a few minutes. It also includes all of ScopeView features. All the features that were seen in the second session of the HyperSim tutorial are usable or are present with TestView too. Another significant advantage of TestView is that it supports both offline and real-time simulation. Therefore, it's possible to develop a test sequence on a personal computer without having access to the lab or having access to the external hardware, and have a complete sequence and then just come in the lab, set it with the target, the OPAL-RT target, and then start the test sequence automatically. Okay, without further ado, let's jump into the first example. This example is using an Arduino in the loop with an OP4510. Here is the context. Let's suppose a colleague of yours is coming with a challenge. He is bringing you an Arduino Uno in which he wrote a hidden code. So he wrote a custom C code in the Arduino IDE, and he is challenging you to figure out what he's doing with that code. Okay, the only information provided are that he is using the input A0. So this is the analog pin located on the analog terminal there. And the output of that code is located on pin number 5, the digital pin that is used as a PWM. Okay. Lastly, the instruction given to figure out is to do a DC sweep and find what is hidden inside the Arduino. In this case, this DC sweep provided would be to do a sweep from 0 volts, then waiting, measuring the output, 0.5 volts, waiting, measuring the outputs, 1 volt, waiting, and measuring the outputs. This kind of process would be very time consuming to do manually. Therefore, the use of TestView for this example. The goal of this video is not to focus on the HyperSim building model part, but rather on the TestView. So here is a quick video montage of building the model with director's comments. The first step is to add the different components. Of course, in this case, I'm using a selector to switch between different inputs that will be fed onto the Arduino A0 pin. And at the same time, we also need to read from the digital pin number 5. Therefore, I'm using the block A out, defining the different names quickly. Here there will be two inputs, the constant DC value to do the DC swipe as requested, and also a programmable event block to provide different duration of pulse input. And ta-dam! Just making sure that the model is running. And the last step is to add the I/O interface for the bitstream to be able to control the different cards. And done! Once the HyperSim model is done, the next step is to make the connections between the OP4510 and the Arduino Uno. First, let's take the OP4510, add the Arduino and connect it to the computer, add the breadboard to the analog out, another one to the digital in, make the connection, and we're done. We are now ready to build the TestView test sequence. Here, as a small note, we know that the input pin is going to be a PWM and we need to measure the duty cycle of that PWM. Instead of doing a logic to be able to count the number of steps and detect the rising and falling edge, I am using directly the PWM features of the digital N. The input of AN1 would be the frequency. This one is expected to be 980 because this is the nominal frequency of pin number 5 of the Arduino Uno. And the AN.UU2 will be the duty cycle itself. Therefore, we want to be able to plot the average value of this duty cycle for each of the tests. So for the 20 tests together. There are several ways to define the parameters from a HyperSim model by using TestView. In this case, we will be using an Excel sheet. The Excel sheet used by TestView has a very simple and straightforward logic. Each row is going to represent one test, and for each of those tests, we can predefine the values that we want to have for a parameter in question. So in this case, we're interested in doing 20 tests for the challenge by doing a variation in the constant input value from 0.5 all the way to 5 and then the other way around. To make this format TestView compatible, since this column is not going to be used by TestView, I'm going to add here an hashtag. In this case, TestView will recognize this column as a comment and it will not use it in the parameters. Afterwards, for the constant input value, we want to modify the input field A, which is the parameter inside the mask. So all we need to do is do the name of the block, constant input, period, the parameter that we want to change. Enter. Here. Lastly, the other information that we need to provide to TestView is the range that we want to use. TestView will not automatically read the whole file. It will only read the range specified in the input of the mask that we will see in a few minutes. To define a range, all you need to do is select the area of interest, right-click on it, and select Name Definition. In this case, we will call it Inputs. You can notice that it added here the name range. Another feature of TestView is that we can also write the outputs or some of the variables of interest directly in Excel at the end of a test or at the end of the whole test sequence. The logic is the same as the input. All we need to do is define the name range. More information about how to configure the Excel file to be TestView compatible can be found directly in the help documentation of HyperSim under the category TestView, TestView Command Excel. We are now ready to open TestView and make our test sequence. This is the graphical interface of TestView. We can see on the left side a project can contain several tests. The middle tab here contains all the commands that we can add to the test sequence. The runner tab is used to control which tests that we want to do. As a side note, it is also very useful to be able to run several tests one after the other, and this is done by using the batch test list here. For any test sequence, the first is always to add this command called hypersim test, followed by hypersim setting. In this case, these hypersim setting, what we can do is to import it directly from the model that is open in hypersim. Therefore, import the network and sensor, then load the different preferences, and in this case, it would be already ready to execute a sequence that is doing nothing for now, but that we will populate. Depending on the type of test that you're doing on the model that you are using, sometimes it is a good habit to add a little delay to make sure that the model is reaching steady state and is stable before running it. I can define the parameter of any block by using this command called miscellaneous here. All I need to do is select the component in question, in this case selection. I want to make sure that the parameter A is always set to 1, like this, and apply. The goal of the TestView sequence is to execute several tests one after the other. In this case, we want to execute 20 tests in a row. To define these loops, we just need to add this block called loop. In this case, we have the option of doing it as a user-defined. So if we wanted to force the number of tests done, or we can leave it unchecked, and TestView will automatically detect the number of tests defined in the range in the Excel file here. Then we can press apply to add it in the test sequence. For models that have a power system in which you want, for instance, to execute some faults, then it can be a good habit to add a snapshot block here and take a snapshot at the beginning of the simulation. In this case, we don't want to take a snapshot at each iteration, but we want to do it after setting the parameter selection. So we can move this command by using the arrows at the bottom and put it correctly at the right place. This snapshot, what it's going to do is that it's going to take the values, a picture of all the current voltage and settings of the model. Therefore, if we're creating a power system test sequence and one of the fault is making the model diverge, by reloading the snapshot, we can come back to the initial conditions, making sure that each test that we're doing have no effect on the subsequent test. We want to make sure that we are loading this snapshot at the beginning of each loop by adding this block. Now we want to get the Excel values by adding the command that is called Excel. All we need to do is define the path of the Excel. It can be located anywhere in the computer. And to specify the name range that we are using. In this case, we defined it as inputs. Then we can import the parameters. Here we can see that it automatically detected 20 tests. This command is similar to scope view when running the model directly from HyperSim. However, it includes extra functionalities to take advantage of the different test sequence that we are doing. All we need to do is to add it. In this case, we would be doing a test of 1 second. We do not need the synchronization since there's no power system. Here, for the key, we can use a scope view template instead of selecting the signals manually. All of those signals that are selected in the signal key will be saved automatically in ComTrade format by TestView. All we need to do is specify the template, scope view template, so the .svt file, and we can, after that, select all of them automatically here. The next step is to save the sensor key. Press OK. Notice here that the processing will generate the equivalent of the scope view template. However, we can also export the data automatically in math file if we want to. In this processing tab, this is similar to scope view. All the functionalities that are available in scope view are also present in TestView, and we can load directly the template as to save time for implementing this test sequence. Something more that we can do with TestView is that we can define some variables here. For instance, average val is equal to the average value of AN UU2. As I recall, UU2 is the duty cycle of pin 5 of the Arduino. So if we add it here, this will record the average for the window for the duration of 1 second in this case, and we'll save it in a variable that is called average val. This variable will be available everywhere in the test sequence afterwards. For instance, if we go in the post-processing tab, we can then add it. And this post-processing will appear an extra graph that is going to be shown at the end of the test sequence and showing the average value for the 20 different tests. There we go. The last element that we want to do after that is to save the values in the Excel file. So all the signals that are going to be displayed or that are recorded in the sensor signal key will be automatically saved in ComTrade format, or also in math file if the option export is selected. The extra signal, the average value signal, we can also save it directly in Excel by using the block table out. In this block here, we can select the option export to Excel to export the data, and all we need to do is specify the name range, which we defined as output previously. Which value do we want to record? We can add the average val, which is the variable that is going to be calculated for the duty cycle of every test, and we can add also general information such as the start of the sequence, the end of the sequence, and so on. So let's do a recap of the TestView sequence that we've just defined. In this case, it will start from the top. The two first blocks are mandatory, the HyperWorks and HyperWorks settings. It is used to make the link with the HyperSim engine and to be able to start and stop the simulation. In this case, notice that I am currently using the local host to configure my test sequence, and later on when connecting it to the target, I will simply change it from localhost to the target number that I'm going to use. Here, as I recall, the miscellaneous, we can move the blocks by using the different arrows. Also, this snapshot is useful in the case of power system to make sure that it is in steady state conditions. However, it is not necessary in this case, so I can simply remove them by right-clicking and selecting delete. It will wait just a little second, and then it's going to go through the list defined in the Excel sheet. We can see here that it defined 20 different tests that it found in the name range inputs, and for each of them it will record all the signals that are part of this sensor key, and it will also display the scope view template that we've made. And on top of all of that, it will also calculate the average and transfer it to the post-processing tab, in which at the end we will see a comparison of all the average values for the 20 tests. The last step, after iterating 20 times in the loop, it will go out of the loop and enter the table out function. In this case here, it will write the results in the Excel file. Perfect, we are now ready to start the simulation and start the test sequence. In this case, I'm going to select the option processing show to be able to see the graphs while the simulation is running. So let's get started. We can see in real time the different commands that HyperSim is executing, and we can also notice that HyperSim itself is being used at the same time that the TestView. So TestView is really just an interaction with HyperSim. We can notice that the simulation has started on the HyperSim side. As I recall, the template that we used was the same one that we loaded directly, so we did not needed to rebuild one from scratch in TestView directly. In this case, a value of 1 is creating 2. Value of 1.5 is creating 4 for the duty cycle of the frequency of the Arduino 0.5. In this case here, let's say that I'm confident that everything seems to be going well, so I will not block TestView, and I will uncheck here the option show. This is dynamic, we can change it while the TestView sequence is running. So I'm gonna close this one, and we'll continue executing the other test without waiting for a confirmation of the user. Therefore, it's doing test number 7, and we can also see different values such as the parameter being used, the test number, and so on. So we just need to go through the 20 tests in this case to see the result of the post-processing tab. And ta-dam! We found what our colleague wrote in the Arduino. It's actually a lookup table that is using the input pin number A0 and outputting the Batman symbol on the PWM pin number 5. The last step is to export to the file. However, TestView couldn't write to it because it was still open. It did not crash. All it did was that it saved it to a new file that is beside the existing one. And it saved all the results that we ask. In this case, the constant and the average value. This sums it up for the first example using the Arduino. As I recall, in this example, we saw the features that we could do a complete test sequence in a few minutes, that we can define several tests inside an Excel file, that we can use existing scope view templates to load and have exactly the same results, reducing the time to create a test sequence. Let's continue this HyperSim tutorial by doing a quick walking tour of the IC60255-121 test kit developed by the AXE team at OPAL-RT. The first example that we saw was a good one to explain the mechanics and see how TestView is interacting with HyperSim and how we implement a test sequence. However, it doesn't show the capability and how far we can go with TestView. Therefore, I wanted to add a little walking tour of this test kit just to give you an idea of how far we can go with TestView. First of all, for those who are not familiar with this standard, it is regarding the distance protection schemes of relays. Here are typical setups that are needed to test the different algorithms for the relay under test, and the standard is specifying 100 of tests to be able to characterize each of the relays and each of its functionalities. Therefore, to do such pre-certification or to validate a relay would be very time-consuming manually, and this is where TestView comes in. If we take a look at the project, we can see that it is subdivided in several studies for each of the different algorithms that are tested. In this case here, we can also see in the middle that a whole study can be executed one after the other by using this bash test list. Another interesting point to mention regarding HyperSim and TestView working together is that it's possible to switch from different model from one test to the other. There is no manual work required on that regard. In this example here, there are about 10 or so models that are developed depending the different type of tests that we want to do on the relay under test. If we take a look at the Excel sheet use, we can see that it's using the same logic than what we did in the first example. Each row represents one test and the header represents the parameter in question. But then if we zoom out a bit, we can see that it can get very serious very quickly. However, something very interesting to mention is that those columns, even though it seems impressive, these are parameters that are defined by equations, depending on some of the predefined parameters in the standard. Therefore, it is quite easy to simply set the different equations and then drag and drop to populate the rest of the test. Lastly, it's also possible to configure several areas of input range, and we can see afterwards the different results being calculated automatically by TestView. From those, it's also possible to generate the reports automatically based on the results of the testing. This concludes this HyperSim tutorial regarding TestView. Thank you for watching.